Hello, my name is Neil Weber, and I'm going to go over what I made in my independent study class. So the idea was to get these pellets to drop from my X500 drone. There's the drone right there. And this is what I ended up making at the end. There's still some final tweaks that I needed to do, but I ran out of time. The idea is I would load these little pellets into the dropper. There's 6 little slots inside there. And on the transmitter, I have 6 different buttons down here that will open each slot point. So I have a total of 5 pellets that I can drop. And how it would attach is just bolted right onto the bottom right here. It would stick out and look like an eyesore, but functionality. So this video is going to go over what I did, any problems that I faced, and how I got to it, anything that I learned in each iteration, because there's multiple different things that I did to get to this final product. Here's what I did to attach the servo to my flight controller so I can be able to drop the pellets that I needed to. Here's what the flight controller specs look like. This is straight from the Matek flight controller. The pad that I attached it to was the S11 pad, which is right here. And then I attached the 5-volt and ground to a spare 5-volt and ground. The reason I chose the S11 pad, this is the same page, just in the ArduPilot mapping. It's in a different group, and so it won't mess with any other groups that I have set up already. So it's a brand new group. And then over here, after I attached it physically to the flight controller, I went over into Mission Planner. I originally had tried to, this is what I was messing around with for probably a good 2 to 3 hours, trying to figure out how to do this. So I went into the setup tab, into full parameters list, tried to find the S11 pad and what it was mapped to, and trying to set it to, I wanted to set it to channel 9 on my transmitter. That didn't work, obviously. And so then I went back into setup, found out that it's really just in mandatory hardware and it's set up as a servo output. Apparently every pad is already set up to do that. And so right here, the S11 pad set to channel 9. That's how I got the servo to be set up and how I plugged it in. So now the servo works on my X500. The next part was to set it up on the transmitter. So here's the screen of the transmitter. I would go to the model, and then I had it over into mixes, and I made my own custom, on channel 9, I set it up to work with these 6 dots up here. And then after I did that, I had to, right here you can see there's a curve. So we'll go over to the curve. That's how I customize when it opens, and how much it opens. So I changed those dots to line up with the slots that I needed. And then when we go back to actually visualizing it, you can see that you're looking right here. So now it works. All right, so I'm going to take you through the prototypes that I went through to get to the final product. First off, we had a plunger method and a tube. This was a later iteration. I threw away the previous ones, but the plunger would basically go through and push the one that's at the bottom out, and a little stopper, so then we can reload it, and then reload, cap it, and then the plunger would plunge it through. Problem that I kept facing with that, binding issues, jamming, and just problems. So from that one, we ditched this plunger, and then the next iteration was actually this. The problem that I had with this one is the length of it. So there used to be a little ledge right here and a little servo. The problem with this, we actually made a little linear actuator out of a servo with these little gears. So when the gear spins, it would create from a circular motion into a linear motion, which was great, but I would only have about 1/4 of an inch throw, which 1/4 of an inch throw would only move it a part of the way. And that was why we went to the last model, which is just spinning it more of like a little pizza method. Went to this. So, and then I cut out this giant piece by hand to hopefully have the servo arm grab it and chuck it out. That didn't work either. It kept binding. And so I thought it was maybe if we make a bigger servo. And so went to this method. The 20 kg servo that we had in this thing, it's right in there, fit onto this. Basically just took this and blew it up 125%. And that would give me about an inch of throw. But the original problems of it binding and getting the angle just right just wasn't working. And so I gave up on the whole drop down method because it just wasn't working. And that's why I went to this. Halfway through printing this one, this plate was way too thick, and so there'd be little to no room for the actual pellets. This one forgot that there is wires on the servo, and so made a little hole for it, and then also made these channels deeper so then the pellets could fit in there. And then this one, which is the last one, that one we made a hole for the wires, ended up being on the wrong side, so I had to manually do the wires. If I did another iteration, I would change the hole and then actually done a through hole so then the servo can come all the way through and there wouldn't be such a fat gap in this. It would close and seal. So that's all the iterations that I did, and things that I learned along the way is just prototyping takes a long time and a lot of patience, and be open to different ideas, because obviously the original idea that I had wasn't really close to what the final thing was. So tweaking things, it was actually kind of fun tweaking through the different prototypes. Another thing I learned that I forgot to add in, test prints. This is an example of a test print when I wanted to make the gear for the linear actuator on the bigger servo. The small servo was a different file than what it needed to be for the big one, and so we just messed around with blowing the whole thing up by 125%. To get it to that percentage, we had to do these test prints to make sure that the gears would actually fit onto the servo and that everything would work well. So we did like a layer or two, put it on the servo. Oh, that is way too big of a hole. So then we made a little shim to go on the actual one. And so we don't waste a lot of time and energy and money on messing up. This is another example of a test print. Halfway through, realized there's not going to be any gap for the actual pellets, and we're wasting a lot of filament that we need to, because the actual gaps didn't start for 1/4 of an inch. So that was another example of doing a test print.